Hello everyone. In this video, we will talk about finding volume of certain solid. This particular lesson will concentrate on the disk method. So what is the disk method? In calculating the volume of certain solid and using the disk method, then we have to find the sum of infinite disk. So this method provides us with a few steps here for us to follow. So first of all, we need to sketch the area bounded by the given function and with a given axis of rotation, in this case either the y-axis or the x-axis, we can determine the variable of integration. So what is variable of integration? Let me go back and remind everyone about the integral of certain function. So if you integrate a function and your differential factor is dx. Okay, so let me quickly write it for everyone here. So if I want to integrate fx, right, then my differential factor has to be dx. So that means the differential factor dx right here will tell me that the function has to be in terms of x when I integrate. So if I have the axis of rotation as the y-axis, then I have to have the differential factor as dy. Alright? Okay. So with the dy, it means that I must have the function in terms of y. So function in terms of y, I can write it as fy, in this case as the integrand, and my differential factor is dy. So this dx and dy's are actually very important for us to find the integral so that we can integrate. Alright, so before I want to get into step number 2 to explain this for everyone, I would like to review a few concepts about the finding the area between the two curves, which we did in previous lesson. Okay, so let me open up the formulas that I have given to everyone. So in previous lesson, we are talking about area between the two curves. So to find area between the two curves, you have to use either these formulas or these formulas. So how do you know that you have dx or dy, right? So because the dx or the dy's are the very important elements. So in order for you to identify this, then you must take a look at the two functions that you have, the two curves that you have. So in this case, I have this diagram for everyone. You are going to choose the element so that it has to touch both curves, right? Both curves in this case. So if you are going to find the dx here, let's say you are going to use the vertical element, then you see that it doesn't fit into the concept of if you place the element right here, then this doesn't touch the other curve. So this one doesn't work. Therefore, you cannot use the vertical element. So if you use a horizontal element, this element will touch both of these functions. So with the dy, you know that you are going to use these formulas. Okay, so this we learned in previous lessons, so I just want to quickly review this to everyone. And if you want to, you have two functions like this, and you want to find the area between these two curves, then let's say you are going to choose the horizontal element. So if I place the horizontal element right here, you see that it doesn't touch the other function. So I have to make sure that I choose the element is that doesn't matter where I place this element, it has to touch both of these curves. So in this case, I have to use the vertical element. Alright, so then let me erase this. So this one is in fact using the vertical elements, and vertical elements is dx. So with the dx, you will be able to figure out what formula that you need to use in this case in order to find the area between these two curves. So this concept is very important in terms of finding the solids. Okay, so let me go back to our lesson, and I am going to show you how the element works in this case. Okay, so let's erase this because this kind of explain that given the axis of rotation, dx or dy, it will determine the variable of your integration. That means you have to integrate in terms of x or you have to integrate in terms of y. Okay, so step number 2 is you sketch the cross section and use the appropriate formulas. So which formula do we use, right? So vertical or horizontal elements should be perpendicular to the axis of rotation. Okay, so the word perpendicular is very important in this case. I would like everyone to remember that. As soon as you have to use this method, just remember that your vertical or horizontal elements will be perpendicular to the axis of rotation. The axis of rotation will always given to you in this case. I will always give you the axis of rotation to work with. And from this axis of rotation, if I ask you to use the methods of disk to figure out the volume of the solid, then you make sure that you have to remember that vertical or horizontal elements should be perpendicular to the axis of rotation. Then we evaluate the boundary of the solids. We set up the definite integral to integrate. Because in order for us to calculate the volume, then we have to have an integral. But that integral has to be a definite integral so that we can get a value. Alright, so I'm going to show everyone these formulas right here. Okay, so this formulas right here that we are going to explore. Alright, so let me circle this for everyone. So we're going to explore these formulas. So first of all, you see V representing volume equal to pi, okay, multiplied by the integral, evaluate from A to B as the upper and the lower limit of y squared times dx. Okay, so I will explain all this to everyone. So now you see about the x-axis, finding the volume of a solid of revolution using this method. So this is very clear. It's asking you to find the volume of the solid of revolution using this method. So it's identified for you that you must use this method, and it's also given you the axis of rotation, as I mentioned in here, will be always given to you about the x-axis and the word perpendicular too, right? Okay, so in calculating volumes, we have to remember the area between the two curves. So to find the area between the two curves, the most important factor is either the vertical or the horizontal elements. So when we talk about the x-axis, it means that I would like you to draw the x-axis. Okay, so x, y, so this is my x-axis. Then, so this is, we call this one the x-axis. Then if we want to choose the element, so either vertical or horizontal in this case, so you just remember that this element should be perpendicular to the axis of rotation. So that means you are going to use the vertical element in this case. So this is my element because this element will be perpendicular to the axis of rotation. Okay, so the axis of rotation is the x-axis because of the perpendicular here. So I have to use the vertical element perpendicular to the axis of rotation. So in this case, I will have, I draw the x. So this element, what is that? Okay, so this element is the dx. Okay, so why do we have dx? Dx is the change in x. Okay, dx is more. Why? I'm sorry, dx is the change in x in the way that you have x2 minus x1, right? So you see right here is your point x2, here's your point x1. You take x2, you minus the x1, you will have the difference in x. So dx in this case is my vertical element, and is perpendicular to the axis of rotation. So y squared in this case times dx. So this is representing the dx that you find here. So y squared is what? That means the function in terms of x, you square that. Okay, so where y is the function in terms of x, axis of rotation is the x-axis. Therefore, we have dx in this case. Because it's obey this rule, this element will have to be perpendicular to the axis of rotation. And then the vertical element was used, and the cross section is a vertical disc as shown below. Okay, so take a look at this vertical disc that I have. I'm kind of trying to prove this formulas for you. Also to explain the definition of the disc method. Alright, so what I have here is this disc. Okay, take a look at this disc. And from this disc, I am going to draw the x and y axis through it. Okay, so I want everyone to concentrate on this area right here. So here's the area that I'm talking about. Alright, so I am going to draw the x and y axis through it. So here's my y axis. So here is my x-axis. Okay, so what I'm going to ask everyone to concentrate on is this is a disc. Okay, so I'm talking about the disc. So this is a circle to everyone, right? So this is a circle. Agree, it's a disc and this is a circle. So how do we find the area of the circle? So the area of the circle is pi r square, right? Okay, agree. So pi r square. So that means I'm going to take pi, I multiply by the radius, but I have to square that radius before I can multiply with the pi. So what is the radius for this area in this case? So from here to here, I have the r. Okay, so that is my r. As I multiply this by r again, and I multiply by pi to get the area of the green part here that I shaded off for everyone. So how do I find the volumes of this disc itself? Okay, how do I find the volume of the disc itself? That means I have to multiply by this one. Okay, let's wash my pen, and I am going to put it in purple. Okay, so I need to multiply by this length. You see everyone, this length right here. Okay, and what is this length? It stays right on the x-axis. In order for me to find this length right here, I have to take the values of this x, subtract the value of that x to find the distance between these two. So this has to be the difference in x, which is dx. This is my dx right here. Okay, so from here to here, everywhere on this is the dx. So to find volumes, I need to do this. I need to write v equal to pi r squared times dx. Okay, very clear. To find the area of this part right here, I will have to take pi times r, and then I square the r, pi times r squared. Then to find the volume of this itself, I have to write volume equal to pi times r squared times dx. Okay, so I am going to ask you to do this. If I take this segment of the dx and I straighten it out, okay, I straighten it out, I am going to draw it like this. Okay, straighten it out, draw it like this. So what element is this? It's the vertical element. And what is this vertical element? This vertical element is perpendicular to the x-axis. Exactly what we have to follow the step. Okay, so exactly what I have here for everyone as the diagram. Okay, so let's me put this in the cloud so that everyone will remember this. Okay, so this is the key. All right, so given the volume of this solid is revolve around the x-axis, and you have to use this method. All you do is just you going to draw the element perpendicular to this axis of rotation, and you find out that it dx. So this is the formulas that you have to use. Okay, so for now we only have to deal with these formulas, but later on we have a few formulas and we have to know which one to choose. Alright, so let me go back and show you this. I developed this sheet for everyone. Okay, so on the sheet here, you see that you are going to have the definition of the fundamental theorem of calculus. So this is to find definite integral. This is to find the area between the two curves, and we reviewed this already. And down here, we are having like volume of integration. We have to find volume of the solid, and we are going to learn this method, shell method, and washer method. So we learn all of this method. There's formulas that we have to follow. So you have to know which formula to choose among these 5 formulae that I put it here for everyone. Alright, so the first one I'm talking about is this method with the dx. So I hope when I show this formula sheet to everyone, you know why I'm trying to concentrate on the dx, the dy, and we have to remember the concept of using this method. So if you talk about this method, then we talk about perpendicular to the axis of rotation. Okay, so let's go back to our lesson. So right now you see just one formulas to work with. Later on you have to use dy and x squared and all that, and then it's actually very simple to recognize if you know the concept. Okay, so let's continue and derive these formulas. So then, in order for me to find the volumes of, let's say I have another shape. So if I add so many of this together, I can find the volume of certain solid. So if I have the sum of all of this disk, it means I have to integrate. Okay, so I can write it like this. The volume is equal to the integral. Okay, so we are working with dx, right? Dx is mean that our upper and lower limit will have to be a and b. Okay, so ab pi r square dx. Okay, so remember the definition of integral. If you have a constant, you can bring that constant across the integral sign. Because pi is a fixed number. Pi is 3.14179, I believe. Then what we do is we bring the pi across the integral sign. So I will have volume of certain solid if I have to use this method, and it's revolve around the axis of rotation is the x-axis. Then in this case I will have volume equal to pi times the integral from a to b of r squared times dx. Alright? Okay, so then what I will do in this case is, what is r? Do you see that r is right on the y-axis? Okay, right on the y-axis. So I'm going to write it as v equal to pi a to b y squared dx. So it's easy just to tell everyone that, alright, so if you have to use this method, you can just apply these formulas if the axis of rotation is the x-axis. But in this case, I want to derive this, let's introduce these formulas for everyone. Okay, derive it and introduce it, so then you can see where the formula is coming from. Okay, so let's move on to the next page. You will probably see a little bit clearer when I'm talking about the summation of all of this disk. Okay, so this symbol right here as the integral is more like a summation. You add so many this together, many of this together. So that move on to the next page. Let me show you this solid right here. Okay, so you see that I have a disk like this. I have one disk. Okay, then I have another disk, then I have another disk, then I have another disk. I have so many of these disks, and I add them all together. I will have the volume for this solid. And the cross-section areas for this is in fact the shape that we talk about in previous page. Okay, so on previous page I have this shape as the cross-section area, and we already went over with this cross-section area is right here. Is the green part that I highlight to everyone. All right, so if you add so many of this together, you will find the volume for this solid in terms of integration. Because in real life, if you want to find the shape of the cylinder, the shape of the sphere, and all that, you have formulas to work with. But with some shape, you won't be able to have the particular formulas to use. Then you have to use integration. So I hope at this point everyone realized that calculus is very important, right? In order for us to work with integration, we have to learn how to work with derivative first. So after we work with derivative, we carry that knowledge on to calculate, to learn how to work with integration. And what is integration for? Integration is for finding the volume of the solids right here. So I put a few points here for everyone to see. The volume of the cross-section can be calculated by V equal to pi r squared times dx. So that is very clear that I explained up here. Okay, the area, the cross-section area right here is A equal to pi r squared. And then to find volume, so this is your dx right there. Okay, so that means you are going to get volume as r times r squared times pi times dx. Okay, if you visualize this, you are going to stack this vertical disk of different size, and this solid generated by revolving the region about the x-axis is shown here. So this area right here, you are going to rotate it. The axis of rotation for this is actually the x-axis. Okay, so then you are going to use this particular formula. So I kind of repeat these formulas for everyone. So I hope everyone kind of understand these formulas, where this formula coming from. So what I'm going to do next is I will quickly go over example number 1. And I know that I only have like 7 minutes left for this video. So I will have video number 2 to show you what happened when we have to use this method, when we have the axis of rotation is the y-axis. Okay, so in this case, we are having the axis of rotation is the x-axis. And using this method, so it's easy because I will tell you what method to use. Find the volume of a solid generated by the area bounded by this curve, y equal to 9 over x, y equal to 0, x equal to 1, and x equal to 8. So very first thing you need to do is you need to talk about the area first. We have to realize what area that we are working with. Realizing the area that we are working with, then you take that area, you rotate it about the axis of rotation that given to you. So in this case, it's the x-axis. So let's identify the area that we have on this graph. So I have y equal to 9 over x. You see 9 over x is the hyperbola, right? It's hyperbola. So definitely this one right here. So follow this arrow that the cursor that I show everyone. So this must be y equal to 9 over x. Okay, so let me highlight it. I highlight it like this. Excuse me. So this is y equal to 9 over x for sure. It's a hyperbola, okay? And y equal to 0. So right here y equal to 0. is definitely this this x-axis, right? Y equal to 0 is the x-axis. So I'm going to write this for everyone. And then x equal to 1. X equal to 1, is it this one right here? Yes, it is. So here is x equal to 1, y equal to 0, and then y equal to 9 over x, and then x equal to 8. Then must be this one, x equal to 8. Okay, so let me do this again. So the most important part is we have to recognize what area that we are working with. So here's highlight the area that we need to work with. All right, okay. Because the idea of finding the volume of the solid is we have to base that on the area that we are working with. So that's why the very first step, very important, is to find the area. Identify the area by make sure that you identify all the functions that you are working with, and then the enclosed area here highlighted. And now go back to take a look at this. We need to use this method, and we need to use the axis of rotation is the x-axis. So I'm going to draw this. This is the axis of rotation. Okay, so with the axis of rotation, it means that the element has to be perpendicular to the axis of rotation. So this element is the vertical element, and this vertical element will be perpendicular to the axis of rotation. So with that, I know that I'm going to use a formula v equal to pi times integral from a to b, okay, y squared times dx. Alright, so let me make sure that I write this properly. So this one is the x-axis. Alright, okay. Let me show you what this solid looks like. If we were going to have a face-to-face class, I would will show everyone, I will probably pass this shape around for everyone to see. So this one is in fact is the 3D of this solid. And let me draw this through for everyone to see. Okay, so right here is your x equal to 1. Right here is y equal to 9 over x. Right here is x equal to 8. And right in the middle of this is actually the x-axis. This is y equal to 0 here. And the area that we are talking about is this area. Okay, now I'm going to rotate this area about the x-axis, and then I generate this shape. Okay, so this area that we are working with, so I'm going to rotate this area about the x-axis. You see the disc right here? See that? It's the whole circle right here as the area. And then you can see that it consists of many little discs that we are talking about. So this. When it rotates about the x-axis, I use the formulas. I am having this shape. So let me show you this shape a little bit more. Okay, so that's how it come to. Alright, so I know that I only have a few seconds left. So don't forget that watch the next video, because the next video I'm going to details how to integrate and finding the values for this solid. Okay, thank you everyone.